So now I want to look at some non-primitive data types that come with most languages. Now, sometimes you have to import a library to use it, sometimes it's directly in there. But I'm going to just show you two examples. There are others depending upon your language and depending upon what you might need. But those two examples I want to show you real quick are strings and dates. And the reason these are non primitive is that they don't exist as just a numeric format that is formatted somehow into a Boolean value or a char or something like that. These are objects. And if you understand object oriented programming and what that means, you're going to understand how that this is a little bit more complex and how it's going to allow you to do more things. So you'll have access to things like, for example, maybe some attributes or some methods that you wouldn't normally have with a primitive data type. A primitive data type just holds the data. So these complex data types and different languages will do different things. For example, in C, you might have a struct, which is mostly and mainly used for just storing data, whereas in C++, you'll have a class, or in Java, you'll have classes, and you can have both methods and data types. So let's take a look at some examples real quick. I've got here in Java first, I have today equals new date. Now, I did have to import java.util.date in order to get that. And I have a string. And so in both of these, for example, I can say today dot, and I can do a variety of things like get time or toString or anything else I might need to. There's lots of other things that I can do. That built-in toString is very helpful because if I want to do system.out print line and I'm going to print today, for example, it's going to take that object, convert it to a string, call that toString method, and this is all being done for me. And so this is what we talk about when we talk about complex data types, is it's doing things for me and I can do additional things. Now, when I go and run this, you'll notice that I get Monday, January 17th, and it gives me a date. I could format that differently if I wanted to use some of its methods that are built in. Likewise, I'm going to say name, and this is going to give me my string. And this looks like a simple string. In fact, you might think of this as, well, is this just a simple string like an old style C string? And in the C programming language, strings were very simple. There was a pointer, and it just carried on until it hit a null character. And so you didn't know how long a string was. It was just data. You couldn't do things like put it to uppercase or compare it to something else. You were very limited. You had to use an external C library that would import a bunch of string processing functions that you could do anything with. But in this case, I can say name dot, and then notice I've got a lot of different things I can do. I can concatenate it to another string and compare it to another string. I can see if it ends with something or is empty, or just a wide variety of things that I might do. I'm going to, for example, set this right now. You notice that it's kind of mixed case. So I'm going to set this to be uppercase. And when I run this, not only is it going to then print out my value, but it's going to make it all uppercase for me. So this is just one of those methods that Java is giving us so that we can work with this and we can do more things with it a little bit faster and easier. We didn't have to go and create this. It's built into a language for us. If I come over here to Python, I get a very similar thing. Once again, I had to import date time. And for today, it's datetime.date.today. So right now I can't do anything with this. I'm not printing it out. So if I want to say print name dot, and then notice I can do a variety of different things. So for example, I might say upper, and when I print that out, and so when I print it out, now I get data structures in all uppercase. So even though I don't have to say like I do in Java, I'm going to create a new string or anything like that. And Java lets me just give it a string when I assign it. I likewise don't have to do that with Python. Python's going to try to figure out, oh, this looks like it's a string, so let me use it as a string. With my date, it's a similar type of thing. So I can come over here, today dot, and notice I can get a wide variety of both attributes and methods. So for example, I want to know what the year is. It's an integer. Or I can come in here and find other values that I might need. If I go and say print today, you'll notice it's going to print out today. Now, it's using the year, month, day format, and I would have to change that myself if I wanted a different type of format. There are ways to change it if I need to, because once again, it's an object, and objects I can call methods, and so depending upon my language, maybe I'll set the default locale print statement. Maybe I will mainly create it for myself. It's just kind of up to you. The PHP programming language has a very interesting date method because of how it's created. And it allows a huge amount of formatting strength where you can put in fixed strings in with it, or you can put in all different types of ways that you want to format your data. So, for example, you can do your month as a number with or without a leading zero. You can do it as a string. You can do it as an abbreviated name as a string. You can do a variety of things like that. You can do that for the days of the week, etc., etc. So your date becomes a very complicated data type in how you format it. What's interesting is it is also very complicated in how it's stored. And that's because your date changes how it's stored based upon the language and the operating system you're using in some cases. So in a lot of computer systems, it is a number that counts the number of seconds from a start date. A lot of times that start date is January 1st, 1970. And so it has a maximum value because it is limited in the number of digits or number of possible seconds that could have passed since then. So just as you're going to run out of numbers in something like an integer or a long, you can run out of seconds that you can store. Now, they constantly go in and make little changes, and there was an update to a major system which would push that number way back, so we don't have to worry about that. So how we do our numbers and how we start to build our data structures, dates are a real interesting way of looking at it because of how they chose. They chose number of seconds from a starting point. Well, what happens if they chose to put it as a day, month, and year? Well, then the question is, what happens if I need time? Well, do I have to store that separately, etc.? And so, do I want to use 3 variables, which takes up more space, and maybe I have a lot of dates to worry about, and then I start wasting space? Or do I want to be very compact and just store one big number and then essentially do a bunch of math? The problem with that is, of course, your math has to be very accurate because how do you handle things like leap years? You can't just assume every year is 365 days. Your date would get off. And so how do you handle those types of things? Those are all things that we have to think about when we're building data structures. The people who built our languages for us already took this into consideration, so we don't have to worry about it. But maybe something else that we're going to build, we have to. So a good example of a thought process, I think, is thinking about dates and how would you store them and how would you want to have the ability to, for example, add dates in the future. So I want to know, what's it going to be like a month in the future or 30 days in the future? What happens if I pick December 15th? I need to add 30 days in the future. What's going to happen to that? So this is kind of an interesting set of problems that you have to think about and you have to consider when you're building out a solution. Is how am I going to handle things like leap years and moving to a different month or a different year? What happens if I get something that's maybe a little bit odd, like Instead of adding 30 days, I want to subtract 15 days. Those types of things that you have to worry about. So whenever you're kind of thinking about how should I build my classes and stuff, especially early on in your programming career, I recommend taking a look at some built-in classes that come with your language that you're using. Start seeing what the developers of those languages thought about and how they work through their problems, because that's going to give you ideas of what other people who are using your language and might be needing to use a library that you're building or a class or package that you're building. It's going to give you insight into how they're going to need to use it. And so it's a real interesting thought process and example that you might want to work through. Now, another common data type that is built into a lot of languages is your array or your list. But we're going to look at that in a future video because that's kind of a special case in how it works. So be looking out for that.